Peter, how are you going to reinvent not just toasters, but the very concept of what human beings know toasters to even be? That's the only mandate.
I feel like when we had a little chat before this, didn't feel like you're gonna open with something like that.
The future of toast is completely on your shoulders. How are you going to do it? Peter Holderith, thank you for coming on Tool or Die. Just in way a quick introduction, you're a auto journalist, have a design. What's your degree in? It's a design degree, right?
Industrial design, yeah.
So you have an ID.
That's like mechanical engineering if you can't do math at all, which I can't. So.
If you looked at a protractor and said that's for chamfers, not for like actually doing anything structural.
Yeah.
Awesome. We actually don't know each other, but we know like tons of the same people coming out of auto and things like that.
Like somebody like unlimited mutuals, but we've never actually met each other.
But the reason I have him on Tool or Die today is because Jim Belosic, I believe is how he says his last name, of SendCutSend started. Is it a contest? You explain exactly like what the terms of this whole toaster thing are.
I feel like I know as much as anybody. I mean, you saw like the whole became a meme, like Made in America toaster. And then Jim got caught up in it and he was like, well, how about I just give people a bunch of money to make toasters? And as far as I know, he gave a lot of people money. And I haven't seen a lot of other toasters, which is kind of disappointing, honestly. But I don't know if it's a competition or if she wants to see some toasters. Like, I just want to see some toasters.
Yeah,
it'd be cool if there's a lot of them.
To frame it out a little bit, this came up. I don't think they were. I think it was just happenstance. But there was a thing that we talked about on the podcast before, where a VC was talking about like you can't even get a microwave made for less than $200 or whatever, which is in the US, which isn't true. But the idea, and obviously it's in the air, is that America doesn't make anything anymore, and which is true maybe in the aggregate, but definitely not true in the specific. But SendCutSend and Jim, the founder, did this contest where he basically said, did he give you money or is he giving you like free parts
He
or
gave
like
me
free
a gift card for a SendCutSend gift card? Yeah.
So it's a challenge basically to the engineering and maker world, which is like, why don't you make a toaster? And Peter actually makes stuff. So he is actually trying to figure out kind of from first principles, if I'm not mistaken, like how to make a toaster. I do want to talk about that, but like, let's go back a little bit, talk about you. You worked as a journalist for a long time. Did you plan to do that when you were going to school? You obviously got an ID degree. How did you fall into that?
Well, so I got my ID degree because I like cars. And by the end of my degree, I was just like, the design for manufacturing side of it kind of like sucked my life out. And I really didn't like it at all. I did several jobs in college doing SolidWorks. I'm pretty good at SolidWorks, so I got gigs to do that. Yeah, I was doing car blogging all through college just for fun. And then I graduated in 2020, so I just got my degree in the mail. I didn't really want a job in design. And then when the COVID hit, I was like, well, I'm definitely probably not going to get one now anyway. Yeah, I just, I worked for Hooniverse. I don't know if you're familiar. Mm-hmm. And then I transitioned that into a night editor job at The Drive. And I was doing research for Donut Media, so 2 part-time gigs at the same time. That was not very fun, but then The Drive worked out. Kyle's a really cool guy. I'm sure you've met him before. So he gave me a full-time gig. And then, yeah, I worked there for 2 or 3 years, and I was at Motor One for a while, and now I'm just kind of doing this.
There is definitely, and it's obvious if you think about it, since cars are one of the last things, like heavy machinery things that are fairly established in the US, there's a massive overlap. And it's been the nature of Tool or Die because Alex and I both come from cars as well. But there is like a legitimate overlap now where people that were coming out of automotive at one of the OEMs or tier ones are starting to get hired up and work on other projects that are outside of automotive, but within manufacturing. I have a feeling as we continue to do this, like that's going to be a big factor. I was even at Wharton a couple of weeks ago. My wife was giving a talk and a kid had a Koenigsegg shirt on. And I went up and asked him like, hey, like where, what's this deal? And he was like at Wharton getting a business degree, but also was on the Formula SAE team and was like, should I keep doing this? And it was like, yes.
I wish I could have done Formula SAE.
So, yes, you did all this car stuff, but it's not a car podcast, as I always say before we talk about cars. But you also are actually, and I think this is when I first noticed, like you are building stuff. You built before this toaster project. There was a project called the Weather Orb or Weather Orbs. Like, tell us a little bit about that.
Yeah. So I love just doing personal projects. I mean, I just love learning so much. I mean, getting new skills is like just fascinating to me. If I think I can do it, and I don't see a reason why I can't, I just try and dive headfirst into it. And doing PCBs is one of those things I wanted to learn how to do because it doesn't necessarily involve a ton of math. It's like the math that is involved can be done by ChatGPT or some other tool like trace width calculators. So, but I was like, well, what am I going to do? I'm really interested in making products more appealing, not by their core function, because that's actually very hard, but by making them just present the information that's already there in like a better way. So that's why I did the weather orbs, and I guess I'll spin my camera around here.
Yeah, if you have one, and I'll describe it
I
for
have
people that are
two.
listening on the podcast. So, you know what it looks the most like to me is a Norelco shaver. It is
Yeah,
a
I got that a lot.
Yeah. Tell about the house, but just so describe it to everybody, it is a piece of electronics that has three orbs set in a rounded triangle that tell you different weather updates and maps, right?
Yeah, so it's three smartwatch displays. So they're legitimately round displays. They have a glass cabochon over them, which kind of magnifies it 'cause it's a small display. And they display weather information, satellite images from the NOAA, weather radar from the National Weather Service. It can do webcams, forecasts. It does coastline surf cameras too. So we have that feature. Pretty much like not anything you want, but a ton of animated stuff, really cool stuff you can put on them. And you can do pretty much three of anything. The core of this project was that these little round displays, whatever you put on them, looks just really cool because it's on a round display, especially when you put the magnifier in front of it. But the question is, what can you put on a round display that when it gets cropped around, because that's all it does, just crops the image. It doesn't, like, there's not vital information that gets lost. And weather radar looks really cool. So it satisfies both those categories. So it's just a matter of actually like achieving that. So I needed a lot of help on the programming side. But I did all the hardware design, all the PCBs. Yeah, I kind of sell them casually now as kits. I mean, I tended just to give them to people as gifts. When I posted it online, people were like, well, I really want this. So I did a batch of 100. I've sold most of them, and I don't think I'll buy another batch when they're out. I want to develop a new one, actually, because they have bigger displays that look even
Now
cooler.
you're talking like an engineer. Now that I solved everything, I'm bored with it and I want to do
Well,
something
there's
else.
like you're just so close to this better kind of device where like so this the screens now only have 7 pins. They're controlled by SPI, which is like a communication protocol. I say that like I fucking know what that means. But it's only 7 pins, but when you go up in size, it turns to like 30 pins. But it unlocks this whole you can go from like 2 inches to like 5 inches. So you could do like these really, really cool looking devices. But again, I'm just like neck deep in projects. That's just one of those on the back burner right now.
I presume you wrote a backend that is feeding the data to those, or is it like just pulling from a web server?
It's just pulling from a web server.
Okay.
Yeah.
Because I think NOAA is maybe getting defunded. It's not clear what is
Yeah.
happening and not happening, but that's been one that in particular I'm frustrated by because I always thought NOAA was a very well run government office and
Yeah.
very useful for a lot of reasons. And
Yeah. So we're having problems with that now, actually, not because it got defunded, actually, but because they put up a new satellite and they replaced one of the satellites and they reorganized how it all works. So we have to go back and fix all that. So some of the images aren't working right now. But yeah, I mean, if that got defunded, I mean, that'd be a huge loss. Putting up satellites together, weather data and stuff like that, I feel like is a very useful part of the government. There's actually really very little competition globally for it, as I found out. Like the EASA, the European counterpart, just doesn't provide data in the same way. It's not as accessible. And in Asia, it's even less accessible. So it's actually very difficult to get it if it's not in North America.
it seems as short sighted as if you were like going to privatize GPS or something, where it's like, no, we've like built this out. This is kind of what the feds are great at. Like
Yeah.
that's why we do it. But nevertheless, you're talking about other projects. So what other projects? We'll talk about the toaster, but besides the toaster, what other things that you have in flight?
Well, a lot of stuff. So the big project I'm working on now is I'm building a hybrid car, a hybrid sports car, which I'm surprised people are not as interested in that as a toaster. It seems like it's totally overshadowed by the toaster. And I'm working on a rapid beer chill. I love Peltier devices and finding use cases for them. Like rapidly chilling beers is actually a very good use case, especially if it's portable.
Yeah, let's talk about both these because I've been keeping an eye on these, and I think Peltier stuff is cool too. Peltier is just like a electrical process to draw heat out. I don't know much beyond that, but it's not super efficient, which
No.
is why you don't see it compared to like a normal gas process for like
Right.
an HVAC or refrigerator. But one, it can be all electric. And
Yeah.
two, you do see it in places. The coolest one, no pun intended, that I have seen in the last couple of years was a shipping company. I went to a logistics conference that had an entire modular Peltier like system where the power was all off board, but it was for trucks for delivery things where they could have relatively inexpensive and leave the crates there with some of the Peltier stuff like the plates
Huh.
in, but then when they returned it, it would hook back up to their system and
Huh.
keep things cold. But why did you make this? What is this, just
Uh,
totally random?
well, so I buy like a lot of, it's not just for beers, for any kind of canned stuff. I buy a lot of like seltzer or Coke Zero or whatever in cans, and I can't fit it all in my refrigerator because they're a relatively small refrigerator. So I enter the situation where I forget to put cans in the fridge or whatever, and I just would just like to have a cold Coke for lunch or something, and I just have to wait like 20 minutes or put it in the freezer. So I want to preface this by saying I made a rapid beer chiller. It's very, very powerful. It consumes a total of like 800 watts, and it does chill a beer in less than 5 minutes. And probably it's just not portable and it requires like two desktop power supplies to run it. And it runs at deadly voltage. So it's like not ideal for a lot of reasons. So this device, these are plausible. And it's a great use case for Peltiers because they're inefficient, sure. But if you're not using a device very often or for very long, the efficiency aspect of it is mitigated. And the other thing that you can lean into in Peltiers is that they're solid state. They don't make any noise. They're lightweight. You don't have to handle any refrigerant. People always say that. They're like, oh, well, it's not as efficient as like a gas cycle heat pump. It's like, well, what they never say is that if you want to make your own, like you have to, or you should. I'm not going to be a cop here and say you have to, but you should get HVAC certified so you can actually handle refrigerants. And like refrigerants are, even if they're not like R134, they're like, butane or propane. So it's still dangerous. At Peltiers, you don't have to do any of that. You have to wire them up. So it's a lot safer, a lot more compact, has the potential to be a lot quieter.
No, and you're not building this for like a commercial thing, so
No.
you don't have to worry about it as much. But the counter argument I would also give is not to you, but to that argument is there's a lot of things that we do for speed, and especially I think of like heat, right? Like we spend a
Right.
lot of energy to heat up food or to cook
Right.
food
Yeah, sure.
really quickly, and it's the same reason we have gas stoves, but we don't heat with gas stoves all the time.
Right.
That would be inefficient. So, but that's not the kind of designer engineer that you are at this point. I think you're really like motivated by trying to just solve a problem and less about like large scale commercial possibility.
In the car project, I am kind of concerned about commercial viability. But yeah, for the rapid beer chiller and for even for the toaster and for the weather orbs, I do these things because I like doing them and I'm curious about them and I want to learn about them. With the car project, it's different because you're a car guy, so you'll know. It's like most new sports cars aren't getting any better. So I remember when I was a kid and I'd drive by the BMW dealership, just like dozens of cars I really wanted. E92 M3s, like Z4Ms, like fresh stuff, like still E46 M3s on like CPO, like fresh stuff, like great stuff. And as I got older, I always expected that the cars would keep getting better. I don't think that was very naive. And it just didn't happen. like this BMW doesn't sell any naturally aspirated cars anymore, which is like insane. It's just like the cars, like with few exceptions, to be fair, like just gradually got more expensive or worse. That's just like so frustrating to me. And that's the reason why I'm doing that this hybrid sports car project.
Well, yeah, frame it up because whether somebody's a car person or not, tell them what you're actually building because nobody else is building it.
Well, the idea is that all the best engines now, all the best modern engines are actually motorcycles. But they rev high, they sound great. There's a lot of unique configurations, just like cross-plane inline fours, which is like you would never put that in the car, but in a motorcycle it actually makes sense. Motorcycle engines aren't very good at key things. Like most of them don't have reverse. They have small alternators, and the clutches aren't good at like pulling cars off the line. And the way you address that is by adding a hybrid system. Actually adds a lot of other cool capabilities too. But it seems like nobody's doing that for it's unclear to me. It's like people say the hybrid system is too heavy, but it's just not. My whole hybrid system is like 120 pounds or less. I was like waiting for some automaker to come out with a concept or some small company to like prove this concept out. And it's just, I was like just so tired of waiting. I wrote a lot about it actually. Like, why isn't this materializing? So I just decided to do it. And Jim actually is sponsoring that project, which is I'm on the I'm kind of on Jim's dole right now.
Yeah.
So I'm doing the toaster for him and this car project. He's funded the whole mock-up and everything like that. And I write about it.
Like, I'd love to talk about the powertrain stuff because I have
Sure, yeah.
similar feelings about hybrid where there what hybrid is so can be so broad. Like you could have a hybrid with an EV range of 100 miles that's going to be wildly different in pack size than
Right.
something that's like 15 miles or whatever.
Yeah.
But talk about it overall, like the system that you're trying to, or the car that you're trying to build is basically in the best case scenario is going to be a kit car project.
So it's like two things. I feel like the sports car market has gotten stale, and kit cars generally are pretty stale. I mean, kit cars are like Shelby Cobras, Daytona Coupes, like that kind of stuff. It's been that way forever. Same kind of audience. I feel like that deserves to be shaken up. I really like designing things for assembly. Like that's actually what I'm doing right now. That's why there's toasters and pieces behind me, because I want to make it really easy to assemble. I actually find that really, really interesting as a concept. And I find the same thing with cars. Like if you can make a car really easy to assemble, if you can make a kit car so easy to assemble that someone would not be intimidated by assembling it, then a lot more people would be doing it. So that's one key problem that I want to solve. And the hybrid system, yeah, I'm not very interested in very high energy, high power hybrid systems. The sweet spot is like 5,200 horsepower because you can keep the battery small. If you keep the battery small, because you don't need very much power, it all just works very nicely. And like one of the worst parts of driving stick is that, in traffic or whatever around town, like you just work in the clutch constantly. And this electric motor, you just like, you throw the engine in neutral and you can just electric like for, I'm estimating like 3 to 5 miles. So it just makes it a more pleasant stick car to drive. It's like, so it takes out the bad parts at like the weight of a passenger. I feel like it's a really good deal. And you can do that cool LMDH bump starting stuff. So there's like subjective improvements and objective improvements to making a sports car when you add a hybrid system.
Well, tell people like when you say sports car, you're building a two-seater? Is
Yeah.
it going to be like a roadster convertible type thing?
Yeah, two-seater open top. I don't for this first prototype vehicle, I don't wanna do doors, and I don't wanna do a roof because it's just like those are engineering projects in themselves. I'm not alone in that. It's like you'll hear people from Caterham or Ariel in the UK are, like, terrified of doors. So when they're saying that, I'm not gonna act like I know better because I definitely don't. And, so I'm just like, "Yeah, I'm gonna do fixed doors this time," which was actually presents its own problems, which is fun. Under 100-inch wheelbase, two-passenger, open-top roadster, front electric axle, rear gas-powered axle, about 200 horsepower peak.
And you're building a first prototype now. I've seen you put some mock-ups up. You also
Yeah.
just so we can do your plugs early so we don't forget. You finally started something on YouTube and like people can follow along.
Yeah.
So is your expectation on this? You do an entire first prototype run and then probably do some like road testing and like actual like drivability testing,
Yeah.
and then you'll go back ideally and do like a for production one if depending on what your outcomes are.
Yeah, so, I mean, it's gonna take definitely a lot of testing. I mean, I know it's gonna take more time, more money than I expect. I do have enough money to build one prototype. Yeah, one prototype, and then I mean, generally, I like to design things 3 times. I don't know if, like, iteration-wise. First prototype, second prototype, and then a third one's usually designed for production, like, production intent kind of vehicle.
And talk
Um,
about the like just the machining and the materials used. So like for people that don't know about kit cars, modern cars, let's see if I can do this quickly, not go too
yeah,
big. Modern cars usually use a bunch of stamped metal, and that's what they call a unibody thing. So a bunch of stamped metal, and then it gets welded or glued together. And then race cars for a long time, or like where I'm from, like hillbilly rock crawler stuff was often tube steel
yeah,
that was like curved and bent, and welded together again. And then so kit cars, which are often like Peter was saying, replicas of old classics, a lot of times, that's not universal, but the people that make the kit cars don't have the money to do stamping. Stamping takes a
right.
lot of money to just build to buy the stamps themselves is often like, a couple $1,000,000. And so they'll build what is effectively just a tube chassis car, like think of a dune buggy or something like that. And then maybe they'll kind of slap bent metal or curved metal like body pieces around it. Um, that's just how I wouldn't call it state of the art. It's probably how it's been since the 70s or 80s, but that's where you get a lot of it. There are exceptions. There was Local Motors and there's some other people that were trying to do some different approaches, but in broad strokes, that's what a kit car is like. And then you even have companies like Ariel and other that are companies that are OEMs, but are effectively kind of just building kit cars in that same
Right.
mechanism. So how much are you using tube? How much are you using new ways of manufacturing? I would presume some of this stuff are things that SendCutSend even can do, like cut plate and things like that.
That's so I talk about this project so much, like some kind of I often miss the point of it. There's a couple of innovations going on, and the big one is that it uses almost no hard tooling in this vehicle. I came to the conclusion quickly that I think you can build cars with no hard tooling. People like SendCutSend and Osh Cut and FabWorks and RMFG are all in that market, and they're all growing the capabilities. By 2030, what I'm trying to do now is going to be easy, and if it's not, like you can fucking shoot me, because it's like it's just happening so quickly. I mean, you had Caleb on. Talk to him. I mean, he doesn't really talk about it publicly very much, but I will tell you that the capabilities they have coming online in the next year are really going to fundamentally change how people make things, especially hobbyists. Same thing can be said for Jim. Same thing can be said for FabWorks. Same thing can be said for Kenneth at RMFG. So all these companies are getting better very quickly.
Explain to people more why, because it used to be the old model was basically, you had factories and a bunch of suppliers and all this stuff, but one kind of big company was putting the capital into funding those factories and a lot of that stuff. And the hobbyist point is a really good one to spend a beat on, because we're 20 years into maker culture or whatever, which was just rebooted Popular Mechanics, and hobbyist culture, 3D printing, CNC, all this stuff. But for a long time, I'd say the last 15 years, there's been like a gulf where everybody got really excited that you could do things like this, and then it turned out what you could do or make with them was not so great. But there's a new era opening up. And so these companies like SendCutSend and OshCut that are able to ship you stuff that they make in their factories that are much more universal, we are able to start doing two things. One, building things that are of higher quality and higher complexity, but also potentially, and Caleb was, we talked to him about this, who runs OshCut. There may be a path here where the universal factory that can supply a bunch of big and small things may start coming online, which is super critical to reshoring.
So all their processes have little or no hard tooling. So they have tube lasers, which are incredible machines. I mean, if you've seen a tube laser work, it's like a truly a machine of terrifying efficiency. Tube bending to over mandrels or not, where they just need dies for various centerline radius or inside bend radii, and like flat lasers. I mean, what you can do with those, and when you combine it with something like what Jim has, which is countersinking, dimple dies, that kind of stuff, like value-added processes, you can make a car of that. Like, if I didn't think that was possible, I wouldn't fucking be trying it. So, I mean, like, these processes are so capable, and they're only expanding. When I was a kid, it was like, I was still interested in getting these parts, like 3D printed parts. But I was like, I'd be like 14, I'd email a company like, oh, I want this part that I can like, whatever. It was like some kind of computer air cooling manifold. And they're like, that's going to be 10 grand, like, to even respond. And it's like, why? Like, I never understood, like, I couldn't wrap my head around why. And everyone would say, like, oh, yeah, I have to buy the tool, all this stuff. And that was just so stupid to me. It's like, I just want a piece of plastic. It's going to cost $10,000. Like, that's ridiculous. And I guess I still carry that today. Like, there's no reason. Well, there is a reason actually, but there's no good reason why I shouldn't be able to get this piece of tube or piece of plastic or piece of sheet metal, just one or two. It's like, because as soon as you have access to those tools, the world is just your oyster. This technology is moving so quickly. And again, like 5 years ago, if you told me this stuff, or 10 years ago, if you told me this stuff was going to be possible now, I'd have been like, no way. Because I wanted to do this, like, car project idea when I was in college and even before that. But it's just like, I could never wrap my head around how I would actually be able to do it. Like, how am I going to get these little parts? How am I going to do this injection? Like, I can't afford this. And now it's all of a sudden possible. It's just amazing. What it's unlocking in terms of reshoring, I think, is huge. A lot of people talk about, like, how are we going to educate these kids to want to be machinists, like want to run machines or whatever. And I think if you give people the keys to these machines, it's like they want to learn about it because they know what they're capable of. I mean, that's what's really key to me. The most important education that, I mean, anybody that I've certainly gotten. I mean, I learned how to do sheet metal because of Osh Cut, because their online DFM tool. Like, I'd never done it before, and like they show you how the parts are made. So it's like, well, now I'm learning about this. Like, so accessing those tools is just, really key to reshoring, really key to education. And, getting one of something is super, super important.
It's not quite what you're implying, but if you keep going on that path, I think a lot about as well. Kids get excited, or I shouldn't say kids because I'm the same way and I'm almost 50, but it's like I get excited and I think people understand what's possible when they get to take something from start to finish. And what's really interesting about now, and I think this toaster project is actually a really good example of this, is over the last decade or two, you had a lot of like science-based kits that were for kids, where there was some Raspberry Pi kits with some robotics, and I'm not dogging any of it. It's fine, but it was a lot of like, hey, we did all of the thinking for you, and it's like Lego. Like follow the
Right.
instructions, you get to the other end, and of course you're learning, and it's good, and you do get some of that satisfaction. But there's a really interesting era now, even like you were alluding to before, the fact that getting a PCB designed custom is the motherboard or main board or whatever you want to call it for people that don't know electronics, where all the transistors and capacitors connect. The fact that you can get a PCB made, even in the US, there's a couple of companies that do it, where you just upload a file and they send it to you. The complexity of what somebody can come up with, the idea they can come up with, is very different now than it was very recently. And this toaster project is such a good example of it, where it's like a toaster is a very primitive machine
Uh-huh.
at its heart. The challenge of it would have not been, can you invent a toaster? It's, can you invent a toaster where you're getting all the parts shipped from suppliers that anybody else would do it, like they were ordering parts from a catalog. And now that is starting to come online. And I think kids will find that, the right kids will see that and go, wait, I can actually make stuff myself that has real utility and function. Answer me more on, or tell me more. I demand answers about the car project. Like, what are the like big block pieces of what you're using? Is it a lot of bent steel? Is it a lot of flat pieces that with a lot of fasteners? Like, what is kind of like the atomic piece of how you're building the chassis?
So the chassis is almost entirely 6061 aluminum tubing. So there's it's very similar. If you ever seen like C6 through C8 Corvette frames, they're actually all very similar. Even the C8 is very similar to the C6 and C7. A lot of extruded aluminum tubes, manual bent rails, a lot of aluminum sheet. So the chassis itself is almost entirely tube. There's sheet. I always say I'm in the bracket phase of doing it right now. A lot of sheet metal all over the place, doing a lot of things for mounting. And then connected to that chassis is a body that the panels are 3D printed, most of them in one shot on very large format machines. And then they get reinforced with fiberglass. And ideally, they get sanded with a robot arm, so you take the finishing out of it. So that way, all these processes are intended to be very, very flexible. So because I think you're going to be able to make sports cars with no hard tooling for the next 5 years with relative ease, you want to come up with a system where you can make a lot of different sports cars. Because if you don't, you're going to get outcompeted because someone is going to come up with a better combination than you. So the idea is that the entire car is very flexible in the way it comes together so that when you come up with a new combination, you can actually execute it. There's several different combinations I want to do. This is kind of just the first one. So I haven't even said what engine is in this car. It's a BMW K1600 bike engine, which you don't know bikes. It's a 1.6 liter inline six, revs to 8,500 RPM, 6-speed sequential attached to it. Just a great sounding engine, an engine that should be in a car,
That's
a hybrid system or not. And but the hybrid system adds so much to it. So yeah, I bought one and it's in my garage. I've been 3D scanning and all this kind of stuff. But yeah,
And for reference, like a 1.6 liter engine, there are many cars that all of you have driven or owned, especially like Japanese cars from the 90s and 2000s that had engines of roughly that size. So it's not a small engine. And actually, these days, the default engine size in most consumer cars is basically 2 liter. So it's not like that much different, but motorcycles engines, as you implied, often tend to rev higher. It's just the nature of how they're used, which is perfect for a sports car. Now on the chassis, to go back to that a little bit, like on the Corvette programs, which I should know this, but are their chassis aluminum tube as
yeah.
well?
So
Okay.
so they do a lot of. So I always love to. I was doing this project when I like started driving, going on C8 programs, and they just loved it. Like Josh Holder, the chief engineer, and Taj, both like very interested. Like when I said that, I said to Josh that you could order laser cut aluminum tube with zero minimum order quantities. He looked at me like, "Are you fucking serious?" And I was like, "Yeah." Like he just kept asking me questions about like what Osh Cut would do, and what all these companies are doing. And yeah, so all the Corvettes have been aluminum. They actually design cars like you or I would. It's like, well, I can't use a casting. That's so fucking expensive. Like they really think about it in that way. They're like, it'd be really nice if we could do this, but we just can't afford that. They really think about cars like a hobbyist would build a car, which is super cool. You would never think that.
Well, GM in particular, and
Right.
I've worked for GM before. I all 000 in the corporate strategy is all the work that I built for them 10 years ago. But Corvette in particular, to me, is if you want to talk about America reshoring and capabilities, there is nothing like, especially the C8, which is effectively not any more expensive than like a pickup truck that is, from a performance standpoint, capable of running with almost any $500,000 exotic. Like, yeah, it's awesome that it's in a sports car and that's fun, but that's like the type of engineering that we need more of and will have to be able to do, which is not bean counter cost cutting because it's going to make it worse, but actually thinking through the process to say, yeah, a cast thing here would make my design job easier, but I'd rather spend an extra 100 hours on the engineering before we go to market and save $2,000 on the price later. And that philosophy is really interesting. Also, Tad's just retired. You should call him and be like, come come help me on this project. And like, you're making a prototype, you don't have to worry about safety or,
Mhm.
I mean, within reason. By using materials that have some tested basis in reality, how are you able to infer like rigidity and safety and buckling and like all of that stuff? Do you have some kind of, can you have some inference from
Yeah,
other
certainly. So
programs?
SolidWorks is a simulation suite, which lets me test all that stuff and gives me the stiffness of it. Again, I'm not an engineer, and I intend for this prototype to be tested. Like I will hire a mechanical engineer to do proper DFM on all of it.
In the driver's seat while you stand
Right.
outside. Yeah.
It's when you're designing a car for enthusiasts, you are designing a different kind of vehicle. When I became an auto journalist, everyone wants to ask you about what kind of car they should buy, which I'm sure
Yeah.
you know.
Mazda CX-5. That's
Yeah,
yeah.
and one question I got asked very frequently was, "Is this car safe?" I had never thought about that ever when I bought a car. That's just not something I ever considered. It's like, well, this car has the engine I want. It's a stick. It's going to rule. That's why I want this car. Is it safe? Like, I give a shit if it was safe. I don't come at it exactly from that perspective. So, because I don't have opening doors, actually a very strong, thick door bars in this car, and the steering column is collapsible, and it has a roll cage that's going to make sure that, if you, God forbid, you roll this car, you will be safe. 4-point harness, all that kind of stuff. A lot of everything passively I can do to keep a passenger safe, I am doing. And there will be testing, absolutely. But just like, yeah, what does Micro say? Safety third. It's like, that is not like my first priority or my second priority.
And it shouldn't be. It shouldn't be. To me, it's more, the question is just like, it's more from that solo engineer standpoint of like, how much do you, how easy is it for you to do and know what you know now? But
Right.
like, if you're doing it all in SolidWorks and it's got a first pass physics simulation, like that will get you to a certain point, and you don't have to do testing until you're ready to sell something to people. And even then, and I'm totally talking outside of my expertise, but a lot of that too in a kit car, you can do a lot of like,
You can do
we
anything.
make no guarantees that this will have, this safety or whatever, but don't take this as like me, like hand waving around. I get infuriated by car companies that don't take it seriously, but at the same time, I ride a motorcycle.
That's kind of what's frustrating to me. From a legality perspective, you can buy like an Expo or whatever, which is effectively a car. Like for all intents and purposes, a reverse trike is a car, but it just has literally no, or effectively like no active safety systems. But as soon as it has four wheels, it's something different completely. That's just extremely frustrating. And of course, yeah. Well, in my state of New Hampshire, seatbelts aren't even compulsory, first of all, but motorcycle helmets are not compulsory. So you can ride a motorcycle with no helmet at 100 miles an hour down 95, or not 100, not legally, but even 65 is deadly speed on a motorcycle. But if you have this, if you're driving something that you made yourself, but has a steel cage around you, you have a 4-point harness and a roll bar, that's not okay. Like that part about it is very frustrating.
So where are you at in the car project as far as like a timeline? Like obviously it's open-ended, but where are your projections right now of?
I want to get it done as soon as possible. So that's actually one of the reasons I hesitated to do this toaster project is because I'm just balls to the wall on building this car, and I really want to get it done this summer. This a car is not just one product, right? There's like multiple parts of a car that could be their own engineering project in itself.
And
Deciding,
are
right, yeah,
generally, yeah.
and deciding what to do there, what parts to buy, what am I getting off the shelf, what am I, all that kind of stuff is very, very difficult. And the problems that you do choose to solve or you have to solve are often a can of worms. 9 out of 10 times they're a can of worms. So it's like, I'd like to get this car in order as soon as possible. I mean, hopefully this summer. Realistically, I might have to wait until this coming winter's over. But it's like a burn. I might have money to do this project, but I also have fixed expenses, right? I have a mortgage, I have bills. It's right. So the faster I do it, the less money I actually spend, right? But I mean, obviously, you have to kind of balance that. But yeah, as soon as I can.
Where are you at as far as the powertrain goes? So if you're going to use this BMW engine, that is not a hybrid engine in its
Right.
design application, and to do a hybrid, you need to, like Peter was saying, the front is going to be driven by batteries and an electric motor, and the rear will be powered by the gas engine. But those need to integrate. Are there off the shelf
No,
like
they don't
integration?
actually.
Why don't they need to integrate?
So I was actually very curious about that. Like, why has no one ever done a rear engine car, mid engine car with the front axles decoupled from the engine itself? Then the E-Ray came out, which is exactly that. And I went on the E-Ray first drive, and I was like, when I was doing this project, I had no idea if I could, with very little or no integration, would these systems actually play well together? So I asked Josh Holder, the chief engineer of the Corvette, I'm like, before you did anything, right? When you just had the electric motor in the car and you had the gas engine in the car, like, did they play nice? And he was like, yes. Yes, they did. Like, they are only coupled together by the road, you know? So it's like, and obviously in the Corvette, they have traction control and stability control and advanced controls that couple them
Right, they have
somehow.
ECUs that
They're
know
aware of
what
each
they're
other.
doing, but
Yeah.
I'm not trying to defend myself. If I'm wrong, I'm wrong, but just so I understand, like, they have to I would think for a vehicle to certainly be at max performance, there would still need to be a control unit or a computer somewhere that knows what the front drive and the rear drive is doing.
Oh, yeah.
I don't mean physically, mechanically
Right.
coupled, but like but you still have some sort of ECU set up in your car. Does your car have a prototype name, by the way? Are you
Uh,
calling
it does, but I don't like to say it. I don't like to say anything about it until it's done.
Pete's car? In
Yeah.
Pete's car, you still have some control that is that is letting the front talk to the back, for
No,
lack
they're
of.
not aware of each other at all.
So then how does that work and it's a race car, so it doesn't need to be perfectly integrated, but how does that work? Do you have a switch that you flip on for the front, or is it just always like the front is always going and the rear's always going?
Well, that's the fun part, actually. That's what's missing from a lot of hybrid cars now. So I was really curious about that too. And there's this guy named Derek Young who lives out in San Francisco, and he put a Kawasaki leader bike engine in the back of a Nissan Leaf. So it's a regular Nissan Leaf, all kosher, but at the back end, there's like nothing going on back there. It's a front wheel drive car. And he put the bike engine back there, and he actually kind of tested this whole theory before I did it. They play very nicely together. They're not integrated at all. They're not aware of each other, and it works very, very well. How you choose to apply that power is something I feel like enthusiasts have always wanted to do. It's like you have this electric motor that probably the E-Ray even gives you very few choices on how to use the electric power. Is it integrated with the gas pedal? Is it a paddle on the back of the steering wheel? Is it a button on the steering wheel that's just a fixed amount of boost? Ultimately, I think I'm going to have to try all those things, see if some of them are redundant. I think for the most part, it's going to have to be up to the driver. It's like if you want, however you want to use it, you actually don't have to use it at all. You can just turn the regen on to 0 and just shut the whole system off, and it's just freewheels. You don't have to use it if you don't want to, but obviously then you don't get the great capabilities of it. You can't, you're going to be riding the bike's clutch. You're not going to be able to run many accessories. You want to reverse, that's going to be a problem. So yeah, these systems do not actually have to be aware of each other for this kind of system to work.
I feel like and I say this as like a terrible racer and not a particularly great driver, but if you're not building in with traction control, then it's basically just a weight distribution and tire grip and like it's a physics problem. But now you've got me thinking where I'm like, I can think of several ways that you could upset yourself by cutting in front power at the wrong time
Yeah.
in a turn or something, but also that's a really fun toy, a new way to put power down, which is basically to be able to do front burnouts
Right.
at any point when there may be a thing where you're in a full lock or a counter steering position where kicking on the front, if it was only inertial before you add the electric power, could do some really interesting
Right.
things. Wow, that's really
So yeah,
cool.
I mean,
Or stupid and deadly, but I
yeah,
can't wait to figure it out.
when I started this project, I didn't start with the hybrid idea. I mean, I thought that if electric sports cars were the next great sports cars, I would have actually built that. But as I learned more and more about electric cars, it's actually why I started building electric go-karts, because I wanted to learn more and more about it. Every permanent magnet motor has almost the same torque curve and horsepower curve. It's basically just limited by inverter cooling is what the actual power curve of the car is. So it's like, that's kind of fundamentally incompatible with sports cars and enthusiast cars generally. They're actually defined by their diversity. It's like a C5 Corvette and an FD Mazda RX-7, or like if you told a non-car person to look at those cars, they might even think they're made by the same company. But they are fundamentally different cars to drive. They could not be more different, but they look almost exactly the same. And electric cars, no matter how different you make them look, fundamentally, they're all going to be very similar to drive. And if they're not, it's like a gimmick, right? It's like a fake transmission, fake exhaust noise. This is what you're seeing play out now is that automakers are struggling to come to terms with how similar all these cars are. The real only differences are like front or rear wheel drive or all wheel drive and like torque vectoring, whatever. But when you dig into that, it's like I never drove a really great sports car. And I was like, man, I wish this would be so much better with torque vectoring. It's like, it doesn't really, it's like, oh, this E46 M3, I wish I had torque vectoring. It's like, no, like it's actually just excellent as it is. So the question became like, okay, so if you want to make a sports car more involving and more appealing, you wanted the person to actually like take the manual transmission as an example. You want them to be more involved with how the car works, like in an interesting way. How would you do that? And it always came back to a hybrid system of some description every single time. So that's why I'm doing this at its core.
I think the word I would underline is involvement. And you really only have two factors in any kind of performance vehicle, which is how fast it can go at its top speed, and then how quickly it can get to that top speed
Right.
again. And like that's ignoring all of the driving dynamics and cornering and all that stuff. But like as far as speed and performance goes, like EVs are great at both of those things.
Yeah. Oh, yeah.
But what they lack is the imperfections or the torque curves being different or
Right.
the decision. It's a UX problem.
Yeah.
It's like they don't
Good
have
way to put it.
like the same consequence for UX choices that any other, like a gas powered car, or frankly you could still do what you're doing with two EVs. Like it could end up being that like having a front and a rear that have independent throttle control is as interesting or more than having, like from a physics standpoint, than having
Right.
the gas engine in the back. Not that I think you're making a mistake, but it's just like that it is the physics thing, that these are physics toys, and learning how to manipulate them on a course or on the road is actually where the joy comes from.
Yeah. I mean, the problem that you really can't get around when it comes to like electric versus combustion engine sports cars is that if you had like an alien, right? And you explain to them how both of these cars worked, like an electric car, a car with internal combustion engine, he might think that a car with internal combustion is somehow intentionally complex because it is an extremely complex thing. We've just gotten really good at making them. And because they're so complex, they're extremely interesting. And it's like, just by consequence of what they are, they're interesting and cool and involving to use. Well, as electric cars are, I find electric cars very interesting and electric drivetrains very interesting, but it's just not the same thing by nature of what it is. So it's like, that's the problem you really just can't get around. It's like, sure, you can add speeds to it. And I've been thinking of like use cases where, say, if you had an electric motor that acted a lot like a gasoline engine, so it was like very efficient or very powerful and a very narrow range of speeds that necessitated a transmission, maybe you could do something interesting with that. But I'm just not sure about that.
A sports car and a race car is ideally more of a sword than a tank, right?
Right.
It's
Yeah.
supposed to be minimal and elegant, and then used, takes skill to use. So speaking of elegant and simple to use, the modern man's sword is this toaster. Like you get the prompt from Jim, he's like, all right, I'm trying to get a few people to build a toaster, and it's a toaster that they could order. Does it have to be 100%? It doesn't have to be 100% for SendCutSend, but like I would imagine, like the bulk of the structural stuff needs to be from there to hit those marks. So where did you start? Like, how did you approach it?
There's a whole philosophy kind of actually I thought of. But I saw Jim was doing this toaster thing on Twitter, and I was like, man, I don't need another project right now. But I was like, fine, I'll do it. I sent him some sketches. He was just like, sure. And he sent me a gift card code. And then I spent like a day and a half just kind of firing this thing together like full speed. And then I ordered it. I thought I was going to be one of the worst ones, and now would be a lot more competition. I'm actually kind of upset I haven't seen more toasters. Because from what I understand, he actually gave a lot of people a lot of money to build a lot of toasters. From what he's told me, he's only actually seen a couple others. I did not expect mine to get as much attention as it did or anything like that.
It looks cool is part of it. You may not think it looks cool, but it looks for a toaster, it looks very cool.
That was kind of part of the philosophy was that so if you're ordering almost all the toaster parts from SendCutSend, you have limitations on what it can look like. You have limitations on what processes they have, and limitations on functionality because you can't make like just from SendCutSend, it's really, really hard to make a fully functioning toaster like that a person would use like they would use a normal toaster. I'm still working on that. So it's like, okay, what does it have to achieve? It has to look cool, like period. First of all, someone don't want to see a pile of sheet metal like this makes toast. It has to look cool. And of course, there's like some national pride going on there, right? If you get tasked to make a made in America toaster and it looks like shit, it's like you're just a schmuck, right? So I knew I had to get that right. And Jim has dimple dyes and powder coating, and those just make incredible looking parts. So when you combine those, it looks cool. And that with some contrast of, sheet metal, some nice looking cutouts, and yeah, just getting all that stuff together. And I did a couple iterations. Yeah, I mean, I got it together in like a day and a half, and now there's the actual challenge of like making it a fully functional toaster.
Do you have heating element? Have you hit to that point yet?
Yeah, that's what I'm working on. So I designed a heating element. That's like another whole can of worms. So like everyone is like, oh, you have to use nichrome wire. If you use nichrome wire, you have to get a sheet of mica. That's how all toasters work. They actually don't even use nichrome anymore, as I learned. These are cheaper. They're all made in China. These are cheaper alternative to nichrome. But I ordered a bunch of nichrome wire. It's actually back in one of these cases behind me. But getting the mica, someone's going to buy this toaster's a kit, right? Because I'm not going to fucking put it together for you. So let me put that up front. You have to buy a sheet of mica and like cut it out to get a piece of toast, like that's bullshit. And no one wants to do that.
Now, I don't understand how a toaster works, so explain it to me. Like the nichrome wire, electricity runs through it, it heats up. That part I get. What is the mica doing?
The mica, so effectively, the nichrome wire, there's current running through it. So you need a high temperature, non-conductive insulator to insulate this nichrome wire from the rest of the toaster. Because if you didn't do that, it would short and the whole fucking toaster would get red hot. So that's actually like the key toaster challenge.
When you say wrap the wire in the mica, you don't mean like down to the wire, but you build like a mica surround.
It's like a sheet of mica. It's like a little piece. It's almost like the size of my wallet. And
Okay.
they just wrap the mica around that into like a long coil. And then that sits
Wrap
next
the nichrome wire around the mica. I got it.
And
Okay.
then that sits next to the toast, and that's what toasts it. And so the whole problem in building a toaster is securing that nichrome wire or your heating element without it shorting out,
Is it
throwing
fragile?
sparks.
Does it like lose a coating or something if you manipulate it?
No, nichrome is not very fragile. The key challenge is the mica. There's actually made in USA mica. So if you wanted to make a toaster in the US, and the wire I got, the nichrome, is made in USA too. If you wanted to go through the whole process of industrializing a toaster made in the USA, you could do it. That's what I learned doing this, is that like when I did the weather orbs, there were certain components that you just could not get in the United States. These were not made here, like displays, extremely in an extreme case. But all the stuff of a toaster you can get here. If you want to start up a US toaster business, you absolutely can. So don't let anyone fucking tell you it's impossible. All right?
How much? I know you're not done yet, but like, if you do you have like a ballpark of what you think a kit would cost, like for doing this? Is it like
at scale?
It's a couple $100.
Yeah, like
yeah.
$200 or $300 probably at scale. I mean, the first prototype cost me like $400 from SendCutSend, just from one, which is pretty fucking amazing considering. But the heating element was a problem that I'm still solving, because the other way to do it is you find the most resistive material in SendCutSend's catalog, which is 304, 316 stainless, and you get enough wire in there. You actually laser a sheet, so it's basically wires, and then you suspend that from ceramic bushings, which are non-conductive and can withstand a lot of heat. You can stick those from McMaster, where it's like you're not going to be asking some guy to be wrapping nichrome wire around a piece of mica that he had to cut out with scissors and punch with a hole punch. You're just going to be bolting in a piece of stainless steel.
I think this is such a smart thing that Jim's doing, because it's like it's not only great for SendCutSend, but what you're talking about, like with the displays and weather orbs. Like, let's be real. Like, you're gonna get this done. Let's say I don't even know, there isn't a prize, but it's like you do it, and everyone's like, yeah, this is the best one, and you make a kit and you sell 100 of them. Like, awesome. That's a cool thing. Totally worth doing. But there's real value in doing more of these type of things at scale, because of what you're discovering on supply chain or availability stuff, which is
Right.
like, if we talk sometimes with people on here of like, hey, what's the estimate of your parts, of your bill of materials that you think is US based? And it's not because I'm trying to nail anybody. It's just more because I want to continue to have a better understanding of where the supply chain is broken down within the US. And what I have also found very interesting, and this is, I'm a layperson, I'm not, I don't come from an engineering background, but it's surprisingly hard in certain industries and almost impossible across all manufacturing industry to just have effectively like a index and a catalog of like, here's all the capabilities. So I'd really like to see more projects like this. This is me asking Jim to spend more of his own money. But it's like, I love these kind of competitions where it's like, it's not it's not for no reason. And some of it is just an engineering feat. When you get your toaster done, and let's say it costs $300 and you'll sell them to some people and it's going to look cool. It'll be a cool conversation piece. What'll also be really interesting is after that, it'll probably be very easy for you, let alone other people, to estimate, all right, if I was going to try to make 100,000 of these a year, how could I do that? And could I do it all US based? And I
Right.
have this feeling that there's a bunch of things in our life, and depending on where these tariffs go, we may have to start figuring this stuff out sooner than later. There's been so many things where people say, well, it could never be built here. And they are usually business types who are going, I can't make the profit margin that I used to make because I offshored all of these things. And if we really do want to reindustrialize the US, we have to work backwards to solve that problem and say, all right, we can't move it all over. It's going to be a matter of a couple of decades, but where are the holes that can be patched near term?
When I did the weather orbs, it's 3D printed in the US, so it has a two-part multi-jet fusion 3D printed case. The front cover, like everything you see, besides the actual displays themselves, ironically, is made in the USA. So all the technology is available. But stuff like the displays, it's a matter of like, you can't just make displays in the US like you can make sheet metal parts. Like, there's a huge capital investment involved to the point where you'd have to have somebody like Apple doing it. Or it's like, it's so hard to draw comparisons between Chinese industry and like American industry because these generalist companies just get loans from the local municipality to build electric motors or build displays or whatever. And they don't necessarily have a market for those products that they're aware of when they start. There are not companies like that in the US, or there are very few. In the US, if you don't use your industry, you just lose it, like, period. Oh, and I was looking for castings for a while, which is frankly, to think that you could get instant coated castings within the next year, which is going to happen. It's just fucking
Yeah, it's
crazy.
on its way. There's 2 or 3 people.
Yeah, yeah. I was like, but the casting industry, I was like, oh, I need metal casting. Almost exclusively serves the automotive industry. Either the industry is very small and specialized, or it got offshored because it's serving a specific industry. It's how they make their bread and butter. A very complex, multifaceted problem. But to say it's impossible, yeah, is not true. I mean, use the auto industry as an example. You're telling me that in the United States, we can build cars that are globally competitive in terms of cost, features, like, efficiency, everything, but we can't build a fucking toaster? That's just stupid. Like, that doesn't make any sense at all. It's a matter of time and money. So you need to get these components back to the United States. People that make these sub-assemblies, stuff like PCBs, metal stamping, those industries need to come back. That's the problem. I was designing a toaster. If I could fucking design a toaster, it's like, that is not the problem, right? Like, the problem is like getting these sub industries back. But to do that, you need to have the demand for that like final product. I don't know what that takes. I think tariffs are a good step. What I would like to see is tariffs going into some kind of grants where it's like, how do you oversight? It's like, it's a big problem. Like, how is there oversight? Like all this kind of stuff. But it's like, if we have all this money from tariffs, it's like, where is it going? It's like, it's just going into a sovereign wealth fund. It's like, you need to reinvest to get these like core industries back so that these other sub industries can actually serve them. Like, that's what you need to do.
In the industries where they chose to play, what China did over the last 10 years and a little bit longer than that is they did what you're describing, where they said, hey, you are going to build an electric motor factory. You are going to build an LCD panel manufacturing thing. And then after you build it, we'll figure out your customers and capability. And, and then it kind of goes into a capitalist thing. I think we were really close in the Biden administration with chips
Uh-huh.
and Build Back Better. There was stuff that was structured correctly, but then when you got to the implementation, and I mean, this is the Ezra Klein, Derek Thompson abundance, position that they've been arguing for the last month. We can do it, and I think that there is a role, and I hope the Republicans understand this as well in the current administration, where the government should be bootstrapping a lot of these big core industry pieces.
Uh-huh.
But I would love to see, whether it's tariff or tax money, somebody, the government, the federal government, or even a state government, it could probably do it, say, here is whatever it would cost, $300 billion thing to build one LCD panel factory in the US, and we're going to make sure that we will support you until you reach a certain amount of demand. And then either keep it state owned and do it like the Alaska Sovereign Wealth Fund with oil, where you say, great, like now that a certain amount of its profits or whatever are always going to go back into the tax base or whatever it is. But I think there's an opportunity that allows American companies to still innovate, to be able to say, we're going to make one of these of each of these industries so we can at least get that part started. But then if that's a universal casting company, they do that once at a certain scale. And then all of these startups that are also trying to reinvent casting and are going to do it, I think, still have a market. But it just needs a little bit of this injection. And unfortunately, what has been happening, the Democrats were as bad, if not worse than the Republicans over the last 30 or 40 years, of saying, hey, we need chips. We're worried about China taking over Taiwan. Let's give Intel a bunch of money. And it's like, don't give Intel money. They chose to go like not build the fabs. Why don't we have a state fab that starts
That
the
actually does
demand?
exist. It's more of an experimental kind of thing.
I would like to see more of that happen, but I will say this, literally your project alone and seeing the stuff or projects that you're working on, and the more conversations that I'm having with people, like I am starting to see the outline of something. This actually could scale in a way that isn't just about a catch up with China, but actually a slightly different approach, where the ideal really is more universal parts factories that can then scale and
Yeah,
service other things.
that that
And
is
I was
really, really key to
even
me.
6 months ago, I was maybe more skeptical of that. Whether you have one or not, I'm going to make you have one right now. Like, what's your deadline for the toaster? Like, when do you want to be done and
What
dusted
is
and
it, May?
move on?
Well, so as quickly as I can. I really want to get back to doing this car. Yeah, I just mostly wait for parts, honestly. I actually design them pretty quickly, but waiting to get them from SendCutSend. So I would say maybe by the end of May.
I've seen a few other people say that they're going to do the toaster thing too,
I
but
hope so.
like when we put this online, like this is the clock's got to start, because like this toaster thing's great, but now we need more of
I
these.
want
We
to
need more
compare
of these
notes with
challenges.
people. It's been a very lonely toaster designing experience. I thought that when I designed mine, and I posted it, there'd be all these other people who are like, I designed the toaster too. I was like, you already did this, and it just didn't happen. Really wanted to do some more toasters. The one thing I wanted to say to your last comment, like this idea of like general factories that can like produce anything. I mean, or not anything, but within a niche, they're very flexible. I do think that's a feature of manufacturing generally. I don't know if you ever talked to Kevin Zinger, who makes those incredible 3D printed cars. That guy, I interviewed him, and that guy like carries his brain around like a fucking wheelbarrow. Like he's really smart. And one thing he said to me in so many words was that like the Rust Belt didn't happen because they couldn't make shit. It happened because of hard tooling. It's because they could only make one thing and they weren't flexible enough to make something that other people wanted. It like kind of pains me to see. Not that I'm have a specific critique on people who are very much kind of counting on some U.S.-China conflict and kind of hedging their reindustrialization on that. But it's like, what happens after that? Like, if this conflict happens, what happens after that? It's like you're building all these weapons of war, and now all of a sudden people need toasters again. The answer is always to get away from this hard tooling. Always. It's like if you want to have industry, the best industry is flexible. It's like, yeah, it's really, really hard to get hard tooling out of something like a car, right? But like the quicker you can do it at scale, that's like the key to everything. Because then you give younger people keys to this process. They get to start innovating. Like the scale of innovation, the accessibility to it, just grows very, very quickly. So, and that's really what's happening now in small scale, like with SendCuts and Osh Cut. So that is absolutely thrilling. That's really what gets me going.
I'm gonna wrap this up by giving you a curse. And the curse is this question: what would be the next thing you would like to tackle after the car and the toaster and everything else?
Well, I have ideas for about 3 other configurations of cars after this one. And I don't really love cars. I love cars as a product more than anything. If I could design and build cars for the rest of my life, I remember I was talking to my professor about one of my college professors about this project a couple weeks ago. He was like, yeah, Peter, you can probably do this, but you'll be into it for 10 years and come out the other side and wonder what the hell you were doing the whole time. It's like, and his name is Peter too. I was like, Peter, if I could do this for 10 years, I'd be in fucking heaven, man. It's like, what are you talking about? It's like, that'd be awesome. That's really what I want to do. If it, moves and makes noise, go karts, I love all consumer products, but things with wheels especially, that's really what I want to keep getting into.
You're gonna be fine. I guarantee you. Like you know why? Because you finish projects. That alone puts you into a different class of engineer.
I want them so bad. It's like with this car, it's like there's only a certain level of motivation I get down to. Like other products, it's like, oh, I'll just get tired of it, stop doing it, take a break from it. With this, it's like a curse because I never know when I'm burned out. So I'll get down to like 20% and be like, but the end product, I know it's going to be so good. I can't stop doing it. I want to drive this car. Like just nothing like this car. I need to drive it. And no one else is fucking doing it. So I have to do it. Yeah, it's again, curse and a blessing. I don't know when I'm burned out.
I'm gonna ping you in about like what's the name of your YouTube channel and stuff if people want to follow you
It's
along?
just my name. It's just Peter Holderith.
I'm gonna let you get back to work. It's been great talking.
Thank you. Yeah, I got to design more toaster parts.